Hello. Yeah, it started. Hello. 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 Yeah. So let's start. Hello, friends. In this video, we will see about how to implement the stack using the linked list. So very first, I want to say is this session is very that making mistakes and learn from it. This type of if you are very advanced in data structures, so you can watch another YouTuber's video. So it is very beginner friendly. So firstly, let's see what is the definition of stack. So in my own word, a stack is a linear data structure which follows last in first order type of operations. Let's see what is a actual theoretical definition of a stack. In computer science, stack is a linear data structure that stores a collection of elements in specific order. What is this order? Last in, first out. Let's see this by visuals. So let me draw one raw stack. So let's assume this is a stack and it follows last in first out order. Last in first out means let's firstly one is pushed means one is entered in a stack, then further two is added in the stack, then further three is lastly added, and it follows last in first out means whatever the elements lastly in the stack will be out first. Means if you have to access the elements from stack, you will access only the last element which is entered in the last. So in this way, stack performs the operations on a data. So let's see some basic operations of stack. So first first operation is push. This operation do what do this operation add the element in the stack. Add the element in. Second operation is pop. Pop means we are removing topmost elements of stack. Removing topmost, or we can say last element. And third operation is pick operation. Pick means we are just picking, means we are just seeing which element is in the top. Just see top element. Yeah. So these are the main operations we are going to perform on the stack. And in the term of linked list, uh, if you have knowledge of linked list, let's assume you are a completely beginner. I will show you how this linked list work. Very span, huh? So linked list it generally stores the element in the nodes, and these nodes are linked to each other through some links. Let's we have these three nodes, and this stores first node stores 1, second node store 2 as integer, third node store 3, and first generally each node has two sections. First section is a data which stores the data, and the second section is a address of second node. This this second attribute of node pointing to the address of second node, and the second attribute which is a next attribute of the second node which pointing towards third node, and third node also has that next attribute, but it does not store anything, so initially it is none. So in this way the linked list is implemented. So in stack, how we can implement the now how we can implement the stack using this linked list? Generally, many people implement the stack using a list and that arrays. But this is a special case. Sometime interview may ask you to implement a stack using linked list. So we are seeing this. Firstly, let's see how many watching us. No one is watching us. So let's come. Firstly, we are adding the first node, which is 1, which has a next pointer none. After that, we will add next node, which contains 2, and the next pointer, which pointing toward the that last element added in the stack. Firstly, the stack have the uh, uh, top element tracker, means that pointer. Firstly that pointing toward the first added. After that it will shift toward here top, and it is pointing to this now. After that we are adding a third node which contain the 3, and it also pointing to this last top, and we are further moving our top pointer to this node. So if we have to access the element, means we have to pop the element, we just know the top element, we don't know the pointer of this, because the pointer of this is stored in the this node, and the pointer of this node is stored in this node. So there is only way to access is leap order, means last in first out, means we just have the pointer of last element. So in this way pop operation does. In pop operation, uh, what we do, uh, we uh, just move this top to next of that top, means Python automatically remove that node using that garbage collector. And we just have the top element which is 2. And how to push element in this? For pushing, just we are creating node, another node, and pointing the next of that node to top, means earlierly top have the pointer in that. So if you didn't understand in the visual, let's see code. There you can understand and clear more about what is happening in this. Firstly, let me take a screenshot of it so we can see this in our VS Code as well. Let me save this in this ABC. So let's remove this code. Huh. Hmm. So here is that image, and here we are creating our code. So first is class node. Uh, let's initialize the constructor. Generally, constructor stores the metadata of that node, means each node have the two fields, which is first is data and next is a pointer to next node. So let's initialize it. Data self dot data equal to data and self dot next equal to none. So these two are the fields in the node. Let's implement the stack class. So we define class named as stack. Uh, in this visual, I said that we are tracking the top element. So for that, we are initializing a constructor here also. Self dot top. So this is top pointer. Initially, it is pointing to none. Further in next step, when we are adding the element, we are assigning address here. So this is a foundational blocks of node and stack. Let's perform some operation. First operation is a push operation. So let's define function for push. Don't forget to take self in it, because self take a whole object of this class. The first parameter, and second parameter is a data. Let's see how to push an element. Firstly, we will create a node, new node, which is an instance of this node class. We are passing a data to it. If you are passing a data to it, it will take a data and assigning it to data. This set node dot data, and their next pointer is none. Firstly, we are adding this one, and the next pointer is a none. After we are adding two, this time we assign this next pointer to the top pointer. So let's see in the code. Firstly, we just created that single node. After that, we are checking if self dot top, means already stack में कोई तो element है, means the stack already have some element. So this time what he does, just assigning that top node pointer to the new node. So new node dot next equal to self dot top and self dot top equal to new node. टॉप वाले पॉइंटर को ऊपर लेके जाएंगे. So using this function, you can add element. What if our linked list is empty? It will not go in this if condition. So for that, doing else. Here we are just assigning that top top pointer to the created node. So in this way we are performing this push operation. So next operation is pop operation. Let's define pop. It also take the object of a cell class, and pop now no pop do not want does not want to does not want that data parameter, because we are just popping out element, so it just take a copy of a cell. So let's see in this picture. We have the three element in a stack. We have to pop these three. What we can do, we just move the next pointer of this. No, we are just moving the that top pointer to the next node. Let p equal to self dot pop self dot. It will store the whole that node in that p. Let's store the data so I can return it. And nextly, let's see how many people is watching us. No one is watching us. It's okay. We are just recording this video. Someone is commented what will be the topic covered. We are covering a linked list, bro. Every day at 11 p.m. I will be live on this channel and covering the DSA topics. So we are here, pop operation. How to pop that element? We are just storing the data of element in one variable and uh, moving this top pointer to the next node. So how to move this? Self dot top equal to self dot top next pointer, means self dot top next pointer. It will pointing to it. We are just moving this top pointer to there, and next node. Till it will be follow, and garbage collector will not remove it. So what we do, one step is here. What we can do, just current equal to top, no, current equal to top डॉट नेक्स्ट. जो करंट का जो नेक्स्ट पॉइंटर है, जो इसको हम एक करंट वेरिएबल में स्टोर करेंगे, टेम्पररी वेरिएबल होगा. और जो टॉप नोड है, उसका नेक्स्ट जो है उसको हम नल कर देंगे. सेव डॉट top dot next equal to none. So this will be that just single node in the heap, that memory heap. So Python garbage collector will that remove it from memory. And we are tracking that this next node, so we are just assigning top to this node. So dot top equal to that current. So in this way we are popping out the element, and after that returning the p, that whatever the data in that removed node. So in this way second operation we are doing. Nextly, this is a simple operation which is a pick. We just picking means we are just seeing that topmost element. Let's define pick, taking a self object and just returning self dot top dot data, means that top nodes data. This is simple function. So these are the three main functions on the stack data structure we have covered in this session. First is a push, we are pushing element in the stack. Second is a pop, we are removing topmost elements from a stack. Third is a pick, just seeing the top element. So in this way we have implemented a stack. Let's run it. Before this, let me read some comments. Yeah, someone is watching. What we have named this file? Stack.py. Stack.py. Yeah, it's successfully running. So here we have to mention some operation on the stack. So let's create one object O. Let's say it yes from stack. You can do anything. Stack. So here we are making an instance of this class, storing it in the yes variable, and let's access the functionality of stack. Let's push yes dot push. uh, uh, let's follow this example. Firstly we are pushing integer value 1 in the stack. After that we are pushing yes dot push 2. After that yes dot push 3. So we have pushed 3 elements in the stack. Generally it will create a nodes for this and making the links according to our code. Now it's time to perform that pop operation. If we let's firstly we perform pick operation so we can see our code is correct or not. So let's pick on the stack. It is returning the value, so we have to print it yes dot pick. So we have called pick. So if our code is correct, then it will return that last element, which is a 3. So let's run it. First we save it and then run it. Yeah, it is returning 3. So firstly we pick 3. Let's perform pop operation. Pop also returning the element, so we can print it just by pop. Yeah, so pop. After that we're again picking what is the top element. You understand? Firstly we are picking. Picking means we are just seeing which is the top element. After that we are popping. Popping means we are removing the topmost element, and after that we are again picking. Is that element is removed, so our top element will be 2. So this is the meaning of these three operations. Let's save it and run it. Yeah, firstly what we have to pick. Pick means we are just see which is the top element, 3. After that we have pop. Pop means removed. Removed, it will remove the topmost element and return the same element. It return the same 3. After that we pick. uh, After picking that, it will see the top element. Top element is 2 because we have already removed that 3. Means we have already popped that 3. So in this way you can implement these stack. In addition, what we can perform in it? Yeah. There is one function I want to show you. It's additional for this. If you want to that print the element in that terminal like this stack, the stack type box, let's implement some functionality for it. What do we name it? We can name it anything. Let's see. Anyone in watching us? Yeah. Two. Hi. I'm very happy that 2 people are watching me. So let's define the function which will perform that printing functionality, like printing this stack on the terminal. What we can name it? Let's name it a print. But sometime Python failed to override that built-in names. So double T here. Print. It will take a copy of self. After that we अरे यहाँ error क्यों दिखा रहा है? हाँ इसकी वजह से जाने दो. So in the stack class, means in the stack object, we have that top element. So first what we can do, yeah, we can implement using a while loop also, but let me think what we can do. Yeah. Firstly we take a current which is a self dot top. So first we'll take a current element which store the that topmost node, and we are just iterating through it and printing. Yeah, it's a simple logic if you have seen my previous video. So let's run while loop. If current dot next is present, means what is the meaning of this? This while loop will run until the current node have next elements. When it will stop? It will stop here because the current node first here. After that it will go to next. After that it will go to next, and here it will stop when it does not have a next element. So this is the meaning of that while loop. So next what do we have to do? We just have to print this type of all here. After that current dot data means that element. After that one more all, these alls you will see in the output. Just see it what I'm doing. So it will iterate. Yeah, next pointer we have to move that current to current dot next. So it will iterate in the that into the list. Dot next. it will perform all these things. After that the pointer will come out and we are printing that bottom olive wall. How to implement it? Yeah, or you can use 4 dot. Yeah. So let's see our function is working or not. Yeah, we are let's remove these things. Well, firstly we are pushing the 3 elements. We have to print it. So just calling that print function. And here it is. Yeah, we are called it. Now let's see the output. Yeah, it is not printing that one because when the pointer come here, what we can do for it? Yeah, here, and we need to check the current dot next. Yeah. Oh, this today disconnected. Yeah, this. Let me see. Streaming is on. Yeah, streaming is on. Connected. So in this way, we can implement the stack operation. So the final conclusion is we have implemented stack with the 4 different functionality. First is push. We have pushed the nodes in the stack. We are popping the nodes from the linked list. Means popping the data from the stack. After that, we are just picking the last element of stack, and after additionally I show the that print functionality that can print that nodes in this fashion, like you can imagine the stack like a bucket type. So it's or so in this way we have successfully implemented this stack functionality. So in the last, just thank you for watching. If you are watching live, it's very good. If you are watching after my video uploading on the YouTube, it's also fine. Yeah, this is all. If you like the video, just subscribe. Yeah, currently 4 viewers are watching the stream. So bye bye. Thank you. Okay.